All right. It says you can mow 10 square yards of grass in 1 minute. How long would it take you to mow a triangular plot 25 yards by 24 yards? Okay. How long will it take? Well, this is, you can ignore that. Yes. Well, stop doing that.
Oh, I'm thirsty.
Well. So you can mow 10 square yards of grass in 1 minute. So how many square yards are going to be? Obviously, if it's a triangular plot, what's the formula for area of a triangle? Okay, so 24 times 25 over 2, which would be 12 times 25, because I could reduce that if I'm doing it without a calculator. And I know that 4 25s is 100. So 12 is 3/4, so that's 300 yards squared. Now, that means that if I have 300 square yards, and every 10 square yards takes 1 minute, that's 30 times 10 square yards, so 30 minutes. Make sense? Yeah. Okay. Applications of geometry. Okay. What? Hairspray. Okay, thank you for your input. Duly noted. You have all your guesses written down? No comments. No, there are a lot. I'm not getting into the guessing game. All right, next question. That is an awesome show, but 30 Dancing Boys is difficult. All right. Yes. Let's talk about geometry. Let's talk about geometry. We'll talk about that later. Not right now. The plan is, if we're going with what we're doing, not to fall. Yeah. Got lots of time. All right, trapezoids then. Let's talk about trapezoids. Basically, there's a big difference between a trapezoid and a parallelogram in that the sides aren't the same. We know that a parallelogram, if we cut it in half down a diagonal, we get two congruent triangles, right? Well, what happens when I cut a trapezoid with a diagonal? I do get two triangles, but they're congruent triangles. No, they aren't anymore. But what is true is that these two triangles both have, I might choose a different little thing this time. Both triangles have the same height. Okay? That triangle and this one, even though it's obtuse, the height would be outside, they have the same height. So even though they're two different triangles, they have the same height, and so we can work with them. So if I call the two parallel sides my bases, so I've got base 1 and base 2, and it really doesn't matter which one is base 1 and which one is base 2. They're just the parallel sides. The area of this triangle right here is 1/2 times the height times base 1. The area of this triangle right here is 1/2 times the same height, because they're the same height triangle, because these sides are parallel, that makes that height be a constant, times base 2. So if I want the area of the trapezoid, I simply have to add the areas of those two triangles together. So it's area of triangle 1 plus area of triangle 2. So 1/2 base 1 times height plus 1/2 base 2 times height. But, and I'll enlarge this just because it's kind of small, I have 1/2 base 1 times height plus 1/2 base 2 times height. Same height. That's the area. But since the 1/2 is common and the height is common, I can factor that out. Algebra. If I factor that out, I get 1/2 times the height, and what is left after I factor that out is base 1 plus base 2. Or a lot of people like to simplify it saying the height divided by 2, which is the same as 1/2 height, times the sum of the bases. That's the formula for area of a trapezoid and where it comes from. Now, a lot of people don't remember how we come up with that formula. That's fine. I'm not going to ask you to figure out how we come up with that formula again. What's going to be important is that you know this formula and you're able to use it. But it's nice to know where it came from, because let's say you forgot it, you can go, wait a minute, that's because there are two triangles there. You might be able to figure it back out on your own, just based on the triangle formula. And some people, when they see the formula, say, well, that's the weirdest thing I've ever seen in my life. Where'd that come from? So I just explain where it comes from so you understand it. If you don't care to know that, you don't have to. But I always think it's nice to at least give the opportunity to understand it if that's something you'd like to do. Okay? So it's height over 2 times base 1 plus base 2. That's the formula for the area of a trapezoid. Now remember, the bases have to be the parallel sides. It's not necessarily the top and bottom. The parallel sides might be left and right, depending on how it's set up. In fact, I've got a couple examples here. One of them, the bases are not the top and bottom. And the height is not always one of the sides. In fact, oftentimes it's not. Just like a parallelogram, it's often inside. So here, find the area of the trapezoid. Well, it's pretty easy. Take the height divided by 2 times base 1 plus base 2. So it's 5 over 2 times 16. Because I have to do parentheses first, adding before anything else. Parentheses first. Now, I could take and turn this into decimal, or I could reduce this way, which is much easier. And that's 40 centimeters squared. Or if you do it in your calculator and do 2.5 times 16, you get the same answer. You still get 40. Here, which side is the height? 6 is the height. Okay? The height is the perpendicular distance between the parallel sides. And the side happens to be at a right angle with both. Therefore, this 6 is the height. The bases, therefore, are which measures? 7 and 5. So that's 3 times 12. So 36 centimeters squared is my area. So we do have to be a little careful with trapezoids. Making sure my bases are the parallel sides, make sure my height is the distance between those parallel sides. Just like the height in a parallelogram is the distance between the parallel sides. And perpendicular. So we're kind of consistent with that idea of height. This is one where we work it backwards. We're given the area, and we have to find the height. So what do we do? This is where knowing your formulas is really important. I know my formula. It's height over 2 times base 1 plus base 2 equals the area. And this is how we use formulas in algebra and in geometry and in the real world. We get a formula, we have an unknown. 8 represents one of my bases, 14 is one of my bases. The height is unknown, so we fill in what we know. I could make it 8 and 14 or 14 and 8. It's not going to make a difference. I know the area. So we plug what we know into the formula, and then we figure out what we don't know. We solve. As long as there's only one unknown, we're good to go. Again, order of operations, we have to do that first. H over 2 times 22 is 143. We keep simplifying this side. 22 over 2 is 11, so 11 times the height is 143. Divide by 11, I get the height is 13 inches. Notice the height would not be 13 inches squared. The height's just a length measurement. It's not units squared, it's just straight units, right? Now, part of the challenge here for some people is, okay, I can get it plugged in there, but I don't know how to handle the algebra for that. Yeah, that's going to be tough. That's one of the things that you need to kind of remember from algebra. We just kind of went over it. Okay, did the parentheses first. Then I reduced that, simplified. It's always, simplify, combine like terms, that sort of thing. That's the simplifying process. So we got to watch that. Could I have multiplied both sides by 2 first and canceled? Yeah, but usually when people do that, they accidentally multiply 22 by 2 again, which you wouldn't want to do. It would be h times 22 equals 286, and then you divide. So there are a few options that you have, but you have to be very careful with the algebra. But knowing the formula obviously is critical. Areas of a rhombus and kite. These go together. What do a rhombus and kite both have in common? What's the common feature for both of them? They both have 4 sides. Yes, okay, I got that one. They have angles. Yes, they do. They have 4 angles. Yes. Kind of similar shape. Rhombus, all 4 sides are congruent. Kite, 2 pairs of consecutive congruent sides. What? Diagonals are what? Perpendicular, right angles? Yeah, that's the key one. That's the key one. Their diagonals are perpendicular. And because their diagonals are perpendicular, when I draw on their diagonals, what kind of triangles do we get inside? Right. We get right triangles. Okay? And because of this similarity, I could go through the whole explanation like we did with the trapezoid. I'm not going to bother this time. But because of that, we get this special formula that can be used for both parallelograms and rhombuses. And that is the area is 1/2 times the product of the diagonals. Diagonal 1 times diagonal 2 divided by 2. And again, a lot of times instead of writing it that way, we write d1, d2 over 2 as our formula. It's the same thing. Kind of saves us from writing the 1/2 out front. Whatever. Okay? Now, for a kite, this is pretty much the only choice we have for formulas right now. For a rhombus is also a parallelogram, so I could use base times height for a rhombus. Couldn't I? So I do have other choices when it comes to a rhombus. I don't have to use d1, d2 divided by 2, but sometimes it's easier. Depends on what information I'm given, which formula I use. So when it comes to rhombuses, I have more than one choice of formula. I have to choose which one is going to be best. Because a rhombus is a parallelogram, I could use a parallelogram formula. But a rhombus is also special and it has its own special formula I get to use in certain cases, if I know the right information. But the formula is the same for both d1, d2 over 2, and that's because of the right triangles on the inside. Okay? And by the way, the diagonal here, d1, d2, means the entire length of this diagonal, the entire length of this diagonal. It is not half of this diagonal times half of that diagonal. It's not half of both diagonals. It's the think of it, I actually kind of prefer this formula because people make fewer mistakes with it. You're multiplying both whole diagonals and then dividing by 2 instead of half of one diagonal times half of the diagonal. Some people get confused with that. So that's our special formula for rhombuses and kites. And that really pretty much wraps up the formulas that we need to know for this first portion of our unit. Or for the most part, does. Because what do we have? We have rectangles, rhombuses, squares, kites, triangles, basically everything we learned about up to circles this year. We've covered all those shapes now and the area formulas for all of them. Most of them were pretty easy. Our new ones today, the trickier ones are the trapezoid and the kite, or the rhombus. So, let's find the area. What type of shape is it? I guess that's, we're going to have to go through a process, a thought process every time we approach one of these problems. First, I need to identify the shape, then I need to know the formula that goes with that shape. So the first one is a trapezoid, yes. What's the formula for the area of a trapezoid? Height over 2 times base 1 plus base 2. So I identify the shape in my mind. I actually write out the area formula. I don't just leave that in my head. I actually write it out with the variables and stuff in there. Now I rewrite it with numbers put in where they belong. Which number here represents the height? The 4. And the bases are 6 plus 8. 6 plus 8 is 14. 4 over 2 reduces nicely to 2. 2 times 14 is 28 square feet. Once we got that formula, all we got to do is plug the numbers in there. Couldn't be easier. What type of shape is this? It is a rhombus. So I could use base times height, or I could use diagonal 1 times diagonal 2 over 2. Now, what I'm given here is a little bit misleading. I'm given this distance is 40 meters. So how long is the whole diagonal? 80. This distance right here is the 30 meters. How long is the whole diagonal? 60. So the area is going to be 80 times 60 divided by 2. What was it, 2,400? Six times 8 was 48. 80 and 60, so it adds 2 zeros, 4,800. Half of 4,800, 2,400. That's how I did that. Trying to teach you a little mental math trick sometimes along the way too. All right? No, you don't want to do mental math? I think I can do this one. Hey, I got to be happy in the little things that I do. Find joy in little everyday things. Okay. Yes? Why you have to divide by 2 in that formula? Right, and if I use base times height, I wouldn't divide by 2. But this formula uses the triangles, okay, uses the fact there are 4 triangles here, and that's how we kind of come up with this formula. So that's why it's a divided by 2 formula, because it creates right triangles. Coordinate plane. This is where a lot of people stumbled yesterday in the coordinate plane problem. If you're given a shape in the coordinate plane, and all the ones you were given yesterday were like this, simply try to find the height and the information that you need. Now, this one happens to be which shape? It's a trapezoid because these sides, top and bottom, are very clearly parallel. These two sides clearly are not. So I can easily find the lengths of these sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This side is 12 because they're just horizontal. I don't really require distance formula or anything here, do I? Horizontals are easy. If the parallel sides are horizontal, what's the height going to be? Perfectly vertical, isn't it? It's got to be at a right angle. So again, I'm not going to need any distance formula. I'm just going to have to count boxes. 1, 2, 3, 4, 5, 6, 7. There's my height. And really, that's all that was required in last night's homework problems that were like that too. If you actually graphed the points, you'd have found that. A lot of people are trying to do it without graphing. We're going to be working in the coordinate plane. That is nothing new. We've been doing that all year. Be prepared for that. When that happens, graph it out. Draw your picture. So again, we know our formula. Area equals height over 2 times base 1 plus base 2. I don't know the area. I do know the height is 7. The bases are 5 plus 12. Now, this is not going to be quite as nice because we're going to get some odd numbers here that aren't going to cancel out nicely with the 2. So that's 3.5 or 3.5 times 17. And I'm fine with the 0.5. 3.5. Oops, not 13.5. 59.5. And seeing as there isn't a unit given, I'm going to give it the unit centimeters as the default. And I found our area. So don't be afraid of working the coordinate plane here. For the most part, a lot of these are given so that you just have to count boxes, basically. Most of you can count. Doesn't require a lot of distance formula. Although, really, seriously, distance formula should not be an issue anymore. Really should not be. It is possible if they ask for the perimeter of this, then we actually would have to use distance formula to find the length of this side. We'd have to use distance formula to find the length of that side. But like I say, at this point of the year, distance formula should be so automatic to you that it's not even an issue anymore. I know it's not, but it should be. So, tonight's homework. There's no vocab. 733, 4 through 48 even, not all. I don't know why 34 and 37 is in there. 34 is already included. Actually, I know why that's in there, because it should be 4 through 28 even.
Well, that changes it a lot.
Yeah. That's got to be a typo, I'm betting. Let me double check that. It is a typo that could greatly improve your life all now, since I caught it. Yeah, it's 4 through 28 even. There isn't even a problem 48, so yeah. 733, 4 through 28 even, 34 and 37. Okay? I will... Yeah, just the evens there too. Don't do them all. Although you may want to do a couple of the odds because the answer for those in the back, so just check to make sure you're doing them right. But seriously, folks, practice here. The homework is practice. You need the repetition and the practice to really do this stuff well. You may think this stuff looks really super easy and that, oh, it's just areas. I've done areas a million times before. Practice doing this stuff. You need that repetition and that practice in order to really be successful on these quizzes and tests coming up. Okay? It really is important. All right. Do the homework.